Hello, Nekomat-senpai desu. In this video, we're going to find the areas under the normal curve. What is a normal curve? A standard normal curve is a normal probability distribution that has a mean equal to 0 and a standard deviation equal to 1. In normal distribution, there is what we call the empirical rule, or also referred to as 3 sigma rule, or the 68, 95, 99.7 rule. It is a statistical rule which states that for a normal distribution, almost all observed data will fall within 3 standard deviations of the mean. So on the figure below, we have here the illustration of the empirical rule. So you can see that 68% of the distribution or data lies within 1 standard deviation of the mean. So from here, -1 to +1. Then 95% of the distribution lies within 2 standard deviations of the mean. So you have here from this -2 to +2. The 99.7% of the distribution lies within 3 standard deviations of the mean. So here you have -3 to +3. Now, we're going to find areas under the normal curve. So aside from from 0, here from the mean 0 to -1, or from here -1 to +1, we're going to find the other areas of under the normal curve given a certain z-score or z-value. So before that, we have here the 4 steps to follow that you need to follow in finding the areas under the normal curve given a z-value. So we have number 1 is you need to express the given z-value into a 3-digit form. Number 2, using the z-table, find the first 2 digits on the left column. And number 3, match the 3rd digit with the appropriate column on the right. And the last step is to read the area or probability at the intersection of the row and the column. That is the required area. So I have here our examples. So now example number 1, you have z equal to 1. So you need to follow the steps, So number 1 is you need to express in this z value into a 3-digit form. So when you say 3-digit form, so here need to add more digits, and the given here is the whole number 1. So that means I cannot see other numbers here, but that means it has zeros on the right side after the decimal point. So for z equals to 1, its 3-digit form is 1.00. So you add 2 zeros now, so that makes it 3 digits, 1, 2, and 3. So third is using the z-table, find the first 2 digits on the left column. So first 2 digits, what are the first 2 digits here? So you have 1 and 0. So you need to look for these digits on the left column. So we are, by the way, here is the z-table. And our z-table is from z equals 0 to z equals 3. So positive z values. And for this, for the negative z values, the equivalent areas are the same. Why? Because here, Okay, you can see that the normal curve is symmetrical at the center. Okay, so that means there is a symmetry. So the area here from 0 to -3, or on the left side, is 50%, and from here 0 to +3, or from the on the right side, is also 50%. Okay, so meaning it is the same, no? So they are symmetrical. So that's why I did not include, no, or there is no z table wherein the values here are negative. Okay, so if you have a negative z value, say for example 1, -1, z equals -1, the area is the same with z equals 1. Okay, so anyway, so let us find that first two digits. So you have 1 and 0 on the left column. So here is the left side, or the left column. So look for 1 and 0. So you have here 1 and 0. Okay, pwede ko siya maano, diba? Sorry. Okay, I can write on this table. I need to speak in English. Okay, then next, so this is your 1, 0. Next is you match the third digit with the appropriate column on the right. Okay, third digit is 0. Okay, the last digit. So look for 0. Okay, you match it. So here, no? Okay, this column, the right column. So that means, okay, the area given that you have z equals 1 is 0.3413. Okay. By the way, in here, okay, here, half of 68, no? Because 68 is from -1 to 1 is actually 34, right? So actually this has a, what do you call this? Decimal numbers, supposedly. Okay, so that's 34%, no? So that's why here you have z equals to 1, is the area is 0.3413, no? So half. Okay, next you have z equals 1.36. So same process. Okay, so no need to write into 3-digit form since this z value is already in 3-digit form, right? Okay, so and go to step 2. So look for the first two digits. The first two digits are 1 and 3. So look for 1 and 3 on the left column. So nasa diri. It's here. Okay, sorry. I always forgot to speak English. Okay, so 1.3. Okay, 1.3 is here. Okay, next is you look for the third digit. You match it. So last digit is 6. So here, in the right column, you have 6. Okay, we'll write a line. Draw a line, I mean. Okay, to match it, so 1.3, 0.06. So that adds to 1.36. Area is 0.4131. Okay. Last example. So you have z equals -2.58. So as what I've said earlier, that for the negative z values, the area is the same with its the positive value. Okay. So if you have -2.58, so just look for 2.58. So first two digits again is 2.5. Okay, 2.5. Again, no need to write into 3-digit form. It's already in 3-digit form. So 2.5 is here. Okay. So here, then look for 8 on the left, right column. Okay, so 2.8. Okay, is it right? Correct. There you go. So 49.8. 0.4951. 0.4951. Alright. So these are now the areas, and you can write these areas into percentage. So what you're going to do is just multiply it by 100%. Okay, so you multiply it by 100. Okay, we'll just write on this part. So that's 34.13% times 100%, 1.31%, and this one is 49.51%. Okay, so that's it. Now, how to find areas under the normal curve. Okay, thanks for watching. Please subscribe on my YouTube channel and follow my page Nekumat Senpai. Thank you.